Good morning. Welcome to class 9 physics, ICSE physics. We are continuing with our Upthrust, Archimedes Principle and flotation. This is part 2, and today we are going to involve ourselves in the questions which are based on Archimedes Principle. The Archimedes Principle, for your ready reference, is given on the other side of the board. The Archimedes Principle states that when a body is immersed in a fluid, it experiences an upthrust, and this upthrust is equal to the weight of the fluid displaced by the immersed part of the body. In other words, the loss in weight is weight in air minus weight in fluid, and that is equal to upthrust in the fluid, the upthrust that the solid experiences in the fluid, and that is equal to V rho G, which we've already seen in the earlier video. Let us look at the question, that is numerical 1. A brass piece weighs 210 GF in air. This tells you the weight of the brass piece in air and 180 GF in water. Find if rho water means density of water is 1 gram per centimeter cube. You are asked to find the volume of the brass piece. Now, we know that weight in air is 210 GF, and we know that the weight in water, W water, is 180 GF, and so we know that the upthrust experienced in the water, according to Archimedes Principle, it is equal to the weight of the fluid displaced by the immersed part of the body, which is the upthrust, and that is also the loss in weight. So upthrust is equal to the loss in weight, which we already know that the loss in weight is due to the upthrust experienced in the body, experienced in the liquid. So upthrust is going to be loss in weight, and upthrust is V rho G, which we already learned in the earlier video, the formula, and the loss in weight is going to be W air minus W water. And so we will have volume into 1 gram per centimeter cube into G is equal to 210 GF minus 180 GF. That gives us V into 1 gram per centimeter cube into G equal to 30 GF. Now this is gram force that we've written, and we have written gram force because we have gravitational acceleration here. So we are going to write V into 1 gram per centimeter cube. We are not going to write G over here, and here we are going to remove this gram force, and we are just going to write 30 grams. So our volume is going to be equal to 30 gram upon 1 gram per centimeter cube. Gram got cancelled, and we have volume equal to 30 centimeter cube. This centimeter to the power minus 3 comes in the numerator, it becomes positive. Now this V is the volume that is displaced by the immersed part. Now since the brass piece was totally immersed in water, this V becomes the volume of the water displaced by the entire brass piece, which means volume of the displaced body is also the volume of solid. So our first answer, volume of the brass piece, is 30 centimeter cube, and that is our answer 1. Now they are asking us to find us relative density of the brass piece. Now relative density formula, as we've already done in the theory part, from any textbook that you are learning, RD, relative density, is going to be equal to W air, that is weight in air, upon weight in air minus weight in water. And so if we substitute, we will have 210 GF upon weight in air, that is 210 minus 180 GF. GF gets cancelled, and that will give us 210 upon 30, and that is 7. So 7 is the relative density of the brass piece, and that is our answer 2. So now we come to question 2. The numerical reads, a body of mass 20 kg is completely immersed in water, and when it is immersed in water, it is displacing 5 liters of water. So we know that mass is 20 gram given, and we have to find the weight of the body in water. That's the first part. Second subpart says find the RD of water, and the third part says density of the body in CGS. Now let us write what facts we know. We know that mass is equal to 20 kg. Therefore, the weight in air automatically becomes 20 kgf. What else do we know? That it displaces 5 liters of water. So, volume of water displaced is going to be 5 liters, which is 5,000 centimeter cube. Now we already know that upthrust is equal to loss in weight of the body, and we also learned that upthrust, it is equal to the weight of the fluid displaced by the body. So we will say it's equal to weight of fluid, in this case it is water, displaced by body. Now, weight of the water displaced is going to be V rho G, where it will be volume of the water displaced multiplied by the density of the water multiplied by G. So that will give us volume displaced by the body is 5 liters. So we will write here 5,000 centimeter cube multiplied by rho of water, that is density, is 1 gram per centimeter cube multiplied by G. That will give us 5,000 grams multiplied by G, which is the gravitational acceleration. And so that gives us 5 kg into G, and that is equal to 5 kgf. Now, they are telling you to find the weight of the body in water. So now we know that upthrust, that is 5 kg, is weight in air minus weight in water, and that is because of the upthrust, which is the loss in weight. So loss in weight is 5 kgf. So weight in air minus weight in water is 5 kgf. Therefore, weight in air, which is 20 kgf, minus 5 kgf comes out to be our weight in water, and so weight in water is 15 kgf, and that becomes your answer 1. You are now asked the RD of body. Now for the relative density of body, we are going to use the formula W air minus loss in weight, that is W air minus W water. The weight in air is 20 kgf, as you can see it over there. 20 kgf upon 20 kgf minus weight in water is 15 kgf, and that gives us 20 kgf upon 5 kgf, and that gives us 4 as the relative density of body, and that is your answer 2. Let's come to the third part, density of the body in CGS. Now density in CGS is numerically equal to RD, and then we will write the units gram per centimeter cube. So we will have RD as 4 and we will write 4 gram per centimeter cube, and that is our answer 3. So we have understood how to complete something like numerical 2. Let us see another type of numerical. We are coming to question 3. A solid weighs 44.4 gf in air and 40.4 gf in water. Find the volume of the solid. What are the facts that are known to us? 44.4 and 40.4 gfs. So we will write the weight in air is equal to 44.4 gf and the weight in water is equal to 40.4 gf. Now according to Archimedes Principle, we know that when the body is immersed in a fluid, it experiences an upthrust, and so it will lose its weight. And this loss in weight, so we will directly write loss in weight is equal to the weight of liquid displaced. Now in this case we have the liquid as water. So loss in weight is going to be W air minus W water. So 44.4 minus 40.4 gf, and that is equal to weight of the water displaced. I'll simply call it as V rho g. This comes out to be 4 gf, and that is equal to V into 1 gram per centimeter cube into g. Now we'll remove this g, that is gravitational, and it will give us 4 gram is equal to V into 1 gram per centimeter cube, and therefore our volume is going to be 4 gram divided by 1 gram per centimeter cube. Gram gets cancelled and that will give you 4 centimeter to the power minus 3 comes in the numerator and it becomes positive, so centimeter cube. Now this volume is the volume of water displaced. We are asked volume of the solid. So we will say therefore volume of water displaced is going to be equal to the volume of solid, and that is equal to 4 centimeter cube, and that is our answer 1. Let us come to the relative density of solid. RD of solid. We remember the formula. The formula is weight in air upon weight in air minus weight in water. And now weight in air we already know, and weight in water also we know. So weight in air is 44.4 GF upon 44.4 minus 40.4 GF. GF will get cancelled, and that will give us 44.4 upon 4, which is equal to 11.1, and that is our relative density of the solid, and that becomes your answer 2. Now let us come to the third part, where we talk about the weight of the solid in a liquid of density 0.8 gram per centimeter cube. Now in order to find that, we need to find first the upthrust in liquid. Now upthrust in liquid is going to be equal to V rho G, and the volume of the liquid displaced will be the volume of the solid, and volume of the solid came out to be 4 centimeter cube. So we will write 4 centimeter cube multiplied by rho, that is density of the liquid, which is provided as 0.8 gram per centimeter cube, and multiplied by G. Centimeter cube got cancelled, 8 4s 32, so 3.2 gram, and I am removing this gravitational acceleration and I am putting 3.2 GF. If this is the upthrust, then the weight in liquid is going to be weight in air minus the upthrust, and that will be upthrust in the liquid. Weight in air is 44.4 GF minus, we found out the upthrust in the liquid 3.2 GF, and when you subtract you'll get 41.2 GF, and this becomes the weight of the solid in that liquid, and that is our answer 3. Let us now come to the last question of this video, the question 4. The numerical reads, a body soluble in water weighs 50.4 GF in air. So we have been given the weight in air, and 28 GF in a liquid. So we have the weight in liquid. We cannot take water because it is soluble in water. So we take the liquid in which it is not soluble. So 28 GF in a liquid of density 1.2 gram per centimeter cube. Find the RD of solid. Now RD of solid soluble in water is, the formula is weight in air upon weight in air minus the weight in liquid multiplied by RD of liquid. All we have to do is substitute. So weight in air 50.4 GF upon weight in air minus weight in liquid is 50.4 GF minus 28 GF, and that multiplied by RD is 1.2. Now if the density is rho liquid is 1.2 gram per centimeter cube, therefore RD is going to be 1.2, because we will divide this by density of water, which is 1 gram per centimeter cube, and the units will get cancelled and you will have RD coming to 1.2. So that will give us 50.4 GF upon 22.4 GF multiplied by, I am writing 12 upon 10. Now let us remove the decimal, and that will give you 504 GF gets cancelled upon 224 multiplied by 12 upon 10. Now here we'll have to start dividing. 2 will go 252 times, 2 will go 112 times, 2 again will go 126 times, 2 will go here 56 times, 2 will go here 63 times, 2 will go here 28 times. Now 4 will go here 3 times, 4 will go here 7 times, 7 ones and 7 nines. So you see in the numerator you have 9 into 3, that is 27, and that upon 10. So we have 2.7 as the relative density of solid, and that becomes your answer 1. Upthrust in liquid. Now according to Archimedes principle, upthrust is going to be equal to the weight of the fluid displaced by the immersed part of the body, which is also W air minus W fluid, which is the loss in weight. So directly we will say this is equal to loss in weight in liquid. So loss in weight of the solid in liquid, and that will be W air minus W liquid. W air is given as 50.4 GF, and we have weighted liquid as 28 GF. So the upthrust is going to be 22.4 GF, and that is the upward force, and that is our answer 3. So now I am sure that you will be able to apply your mind, and you will be able to understand how to solve the questions based on Archimedes principle and relative density. Thank you for watching.